Hello everyone, I'm going to go through the first worksheet that's posted on Canvas, which you are supposed to work on after you complete the material on chapters 1 and 2. All right, so I'm going to give you the solutions. You are supposed to work on the worksheet yourself first, and then if you get stuck or if you are confused how to proceed with a particular question, please watch this video and I'll try to give you the solutions as well as explain the answers. All right. Now, the first question says, based on a random sample of 1,000 people, a researcher obtained the following estimates of the percentage of people lacking health insurance in one US state. So they've given us the data over here. They are trying to study what percentage of people do not have health insurance coverage in a particular state in the country. So they have arranged the data, organized the data as in table form, right? A frequency table. Well, this is not quite frequency table, but it is derived from a frequency table. They've given us the percentage of people not covered, and then they have grouped the individuals by ages, so 18 to 24, 25 to 39, and so on. And in the second column, they've given us the percentage not covered. Now, you should all know by now that the percentage can be obtained from relative frequency. So once you put together a frequency table, you find the frequency values. From there you can get your relative frequency values, and the relative frequency values give us the percentage. When you multiply those relative frequency values by 100, you get the percentage form. All right. The question given to us here is, classify the data as either descriptive or inferential. Now, let's quickly go over the difference between descriptive statistics and inferential statistics. Descriptive statistics is performed entirely on the sample. So the first part of any statistical study is to obtain or rather create a sample, administer a survey on the sample, and then collect data from the sample. And once we have the data from our sample, we perform descriptive studies. That means we measure the data, we analyze the data. Of course, before that, we have to organize the data before we can go into taking measurements. But all those are a part of descriptive study, and descriptive study is done entirely on the sample and is done on actual data. Inferential study, on the other hand, is performed for the population, and we perform inferential study based on our sample measurements that comes from the descriptive part of statistics. So inferential study really involves drawing conclusions, making estimates on the wider population based on the descriptive study which we did before that. All right, before we get to the inferential part, we have to perform the descriptive part. Now, I'm going to go back and read the question one more time. It says here, based on a random sample of 1,000 people, a researcher obtained the following estimates of the percentage of people lacking health insurance. So let's look for some keywords in the question itself. All right, so the keywords are based on a random sample. Based on a random sample of 1,000 people, a researcher obtained the following estimates. This is a key word here, estimates. So what they have done is they have drawn estimates, they have drawn conclusions based on a study done on 1,000 people in a sample. All right, so whenever you come across these words in the question, you can pretty much assume that this is going to be inferential statistics. All right, so I'm going to write here, it's inferential study. All right, now let's go to the second one. Same type of question. They're asking us to decide whether the study is descriptive or inferential. But the question says here, the table below shows the number of homicides in the US in each of the years 1989 to 1993. So we have again our data arranged as a table, frequency table. In the first column, we have the different years starting from 1989 going all the way to 1993. And in the second column, we have the number of offenses, number of homicides that occurred in each of these years. And that's all it says. All right. It doesn't say whether this is a sample study, whether this is an estimate. It says that the table shows the number of homicides in the US in each of the years. So this is actual data based on the information provided to us. We can pretty much assume that this is actual data. And therefore, this is descriptive statistics. All right. This is descriptive statistics, because it doesn't say anything about estimates. It doesn't say whether a sample was drawn or not. This is actual data for the entire country over these years. So that tells us this is descriptive data. Now, question number 3 says, a researcher randomly select a sample of 100 students from the students enrolled at a particular college. So that means a sample of 100 students were obtained from the students at a particular college, and then the researcher asks each student his age and calculates the mean age of the 100 students. It is 21.3 years. Based on this sample, she then estimates the mean age of all students enrolled at the college to be 21.3 years. In what way are descriptive statistics involved in this sample, and in what way are inferential statistics involved? So we have to make a choice. They've given us 2 choices, A and B. Let's read through the choices, right? It says, when calculating the mean age of the students in the sample, the researcher is using descriptive statistics. When estimating the mean age of all students at the college, the researcher is using inferential statistics. What do you think? Right? When we take measurements on the sample, that's the part which is descriptive statistics, correct? That's what we just talked about when we were working on the last 2 questions. So the first part of the sentence in A seems to be correct, right? When calculating the mean age of the students in the sample, the researcher is using descriptive statistics. That's correct. When estimating the mean age of all students at the college, the researcher is using inferential statistics. Yes, inferential statistics involves estimating the mean age from the descriptive study performed previously. So it seems A is the correct answer. However, let's go through question B also, not question B, the option B. When calculating the mean age of the students in the sample, the researcher is using inferential statistics. No. Right? When calculating the mean age, whenever we work on the sample, whenever we take measurements on the sample, any work done on the sample is descriptive statistics. Any estimation, inferences, conclusions drawn from the sample study or the descriptive study is inferential statistics. So that's the problem with B. B says that the mean age, the calculation of the mean age of the students in the sample is inferential. This is incorrect. And then when estimating the mean age is descriptive, no, that's incorrect. So A is the correct choice. Now, number 4 says, a magazine publisher mails a survey to every subscriber asking about the quality of its subscription service. The total number of subscribers represents what? Is it the population or is it the sample? So let's again read. All right, for many of these questions in statistics, in fact, for every question in statistics, you should go over the verbiage, the question multiple times. All right, once is not enough. You will need to read it at least twice to come to the right answer. So it says a magazine publisher mails a survey to every subscriber. So that's the key word, every subscriber, asking about the quality of its subscription service. So every subscriber represents the population. All right. So the answer should be population, not the sample. It's the population. The two choices given to us were population and the sample. Since they've mailed it to every subscriber in their list, it's going to be the population. All right. Question number 5 says, a magazine publisher always mails out a questionnaire 6 months before a subscription ends. This questionnaire asks its subscribers if they are going to renew their subscriptions. On average, only 3% of the subscribers respond to the questionnaire. Of the 3% who do respond, an average of 40% say that they will renew their subscription. The 3% who respond are they the population or are they the sample? That's what we have to decide for this question, right? So let's try to understand again what this publisher is doing. The publisher sends out sends out a questionnaire asking all their subscribers if they are going to renew their subscription. All right. Now, they sent the questionnaire 6 months before a subscription ends. So keep in mind, they are not sending out the subscription to all their subscribers, to only those subscribers whose subscription is going to end in the next 6 months. All right, after 6 months from the time they send the letter or the questionnaire. All right, so that itself tells you that it's not the entire population. All right, they're sending the questionnaire to certain subscribers whose subscription is going to expire in 6 months. The questionnaire asks its subscribers if they are going to renew their subscriptions. On average, only 3% of the subscribers respond, and of the 3%, 40% say that they will renew. Now, the question is, of course, about the 3% who respond. Are they the population or the sample? Clearly, they are the sample because they do not represent the entire, they are a subset of all the subscribers. All right. In fact, they are a subset of the subset. The subset, when the magazine publisher sends out the questionnaire, they're sending it out to a subset of the entire population of subscribers, right? Only those whose subscription is going to expire in 6 months, and then of that subset there's another subset of just 3% who respond. All right, so clearly this is the sample and not the population. Now question number 6 checks whether we understand the difference between experimental design and observational study. All right, so there are two ways in which we can collect data. All right, one is called the experimental design. So we obtain our data by creating an experimental setup and then performing an experiment. And the other one is sending out surveys, questionnaires, or just mere observation. That's called observational study. All right, so the question says 400 patients suffering from chronic back pain were randomly assigned to one of two groups. Over a 4-month period, the first group received acupuncture treatment and the second group received a placebo. Patients who received acupuncture treatments improved more than those who received the placebo. Identify the study as observational or experimental design. So, it's only in experimental design where we set up two groups. One group is the treatment group, and in this case, the first group received acupuncture treatment, and then the other group, which is called the control group, received the placebo. Placebo means that they kind of received a false treatment is not the right word, but a pretend treatment, so to speak. They did not get the real treatment, the actual treatment, but they were given something which appeared to everyone that they were getting a treatment, but it was actually no treatment. All right, it was just a pretend treatment, so to speak. Now, patients who received acupuncture treatments improved, and those who received the placebo didn't improve as much as those who received the real treatment. So this is clearly a case of experimental design. So our choice is experimental design. If you go through the material on Canvas on this topic, experimental designs, that's how an experimental design is performed. They divide the sample into two groups. One is the experimental group, the other one is the control group. They administer the medication or whatever study they want to do on the experimental group, and the control group is really given a placebo or a pretend medication, and then they compare the results. All right, so this, based on the wording, the verbiage of the question, this is clearly a case of experimental design. Number 7 says, an examination of the medical records of 10,000 women showed that those who were short and fair-skinned had a higher risk of osteoporosis. Identify the study as observational or experimental design. Now, there's no groups here. There's just 10,000 women. Nobody even reached out to those women. They just looked at their medical records, examined their medical records, and obtained the data from there. So this is a case of observational study. All right. So these two questions, number 6 and 7, really tested us for whether we understand the difference between experimental design and observational study. Now, the next set of questions is about creating all possible samples from a certain population, all possible samples of a certain size from the population. All right, so let's read through it first. It says the finalists in an essay competition are Lisa L, Melina M. So these are just, we are denoting them with these initials instead of referring to them with their full names. We just refer to Lisa as L, Melina M, Ben B, Danny D, Eric E, and Joan J. Consider these finalists to be a population of interest. The possible samples without replacement of size 3. Let me bring up my pen here. All right. Of size 3. These are very important. That can be obtained from the population of 6 finalists are as follows. Now, we have to first come up with all possible samples of size 3 from a population of size 6. So the candidates given to us are Lisa, Melina, Ben, Danny, Eric, and Joan. We have to create all possible samples of size 3. We have to draw names to come up with 3 people at a time, and we have to list all possible samples. So let's go about doing that. Now, I'm going to use the tree method of coming up with the samples. Now, you could go ahead and do it in your head, but it can be really challenging to do that, and there's a chance that you might miss a particular sample. All right, so it's important to get all possible samples to work in a certain organized and structured way, and I will show you the tree method of doing that. Right, so what I'm going to do is I'm going to list all these initials first, have it before me. So we have L for Lisa, M, and then B, and then D, E, and J. All right, now what I'm going to do first is start with L, and I'm going to make 3 draws. We need samples of size 3, so there are going to be 3 draws. It's like pulling a name from a hat, and we have to make 3 draws. We have to pull the names 3 times. All right, so to get that sample size. So I'll start with L. Now let's say in the first draw we get an L, then in the second draw we can either get M, right? This was the first draw. Now we go on to the second draw. In the second draw we can either get M or B or D or E or J, correct? So M or B or D, every person has an equal chance of getting drawn. This is simple random sampling. And then we have, or we could get E, Eric, or we could draw J, Joan. All right, all of these have an equal chance of being drawn in the second round. Now we have 2 so far. We need a third draw. We need to draw the name of a third person. So we start from, for after M, we can either draw B, Ben, or Danny, or Eric, or Joan, right? So we can, if we've drawn M, then in the next round, it's all without replacement. So if we've drawn M in the previous draw, we cannot get M in the third draw. All right, it's without replacement. That's important. So from M, we can either get B, Ben, or we can get D, Danny, or we can get Eric, or we can get Joan, correct? If it's B, then what are the names that come after B? We can either draw D or E or J, right? From D, if D is drawn in the second round, then in the third round we can either get Eric or we can get Joan, correct? E and J. And then what comes after E? This only person remaining is J, and if J was drawn in the second round, then there's nothing else that comes after J, so J drops off. All right, so let's walk the tree now to pick up all the combinations. So what I'm going to do is LMB. So we are walking the tree. LMB, LMD, LME, LMJ. So I'm going to list that over here. All right. So let's list that. LMB. All right. That's 1, 2 is LMD. So LMD. Then number 3 is LME. So LME. Then the fourth sample we get is LMJ. So LMJ. Then number 5 is LBD. All right, LBD. So LBD. Then we have LBE. LBE. Number 7, sorry, I skipped one. Number 7 should be LBJ. So we are essentially walking the tree now. But we are not done with L's. We have to start a few more trees. So just hold on, just be patient and hang in there. LBJ, we got that one. Then we have LDJ. No, we missed LDE. Sorry. LD. So make sure you're walking every branch of the tree. LDE. Because if you miss one, then you will not get all possible samples. And then we have LDJ. And then the final one is LEJ. Okay, LEJ. So 10. So now we have to start a tree with M. We've done all combinations that will have L in it. Now we start with M. So I'm going to start here M, and then from M we can, in the second row, we can either get a B or D or E or J, correct? And then after B we can either get a D, E or J. Then from after D in the third round, we can either get an E or a J. And then after E comes J. And then the last one always drops off the tree. All right, we don't, because there's nothing that comes after J. We need samples of size 3. All right, this will not give us a sample of size 3. So now let's walk the tree and continue making our list. So number 11 is going to be MBD. Then number 12 is MBE. Then number 13, MBJ, right? So MBJ, then MDE, 14, MDE, then 15 is MDJ, MDJ, and then MEJ. All right, now we are done with M. All right, L and M are over. We have completed all combinations that will have L and M in it. Now we have to work with B. So start another tree beginning with B. So after B, we can either get a D or an E or a J in the second round. In the third round, from D, we can either get an E or a J. So E, J. And after E, there's only J. And the last one always drops off. So let's continue with our list. 17, B, D, E. 18, B, D, J. And then B, E, J. 19, B, E, J. All right, so we're done with B's, all the combinations that will have B's in it. Now we have to begin with D. Another tree starts with D. So in the second row, we can either have an E or a J. And in the third row, from after E, we either get, we only get the J, and this one always drops off, correct? The last one. So number 20 is D, E, J, and we stop here, all right? Because we are looking for samples of size 3, there's no point doing another tree with E, because it won't give us a sample size of 3. The only thing that comes after E is J, and if we were working with samples of size 2, then yes, we would have to do another tree with E. But since this is samples of size 3, we've covered all possible samples now, and there are 20 of them. 20 unique combinations of size 3 that can be drawn from a population of size 6. All right, so this represents all combinations. Again, like I told you, it will be challenging to do it in your head. If you can, go ahead, but I think this tree method helps us helps us proceed in a structured way and helps us capture all different possible combinations. Now, there's a follow-up question here. It says, if a simple random sampling method is used to obtain a sample of 3 of the finalists, what are the chances of selecting Ben, Danny, and Joan? So that means it's asking, what is the chance of getting a combination that will have Ben, Danny, and Joan as a combination? All right, so how many combinations did we have? 20, right? So there are a total of 20 possible samples, 20 unique combinations, possible samples, of which how many combinations do we have with Ben, Danny, and Joan? Of which there is, let's see, BDJ, there's only one BDJ. Just hold on. Let me take care of this. My writing has started moving up. All right, sorry about that. BDJ, there's only one combination which has BDJ in it. I don't think any of these combinations have BDJ. So 1 out of 20, of which only one has, what is it, Ben, Danny, and J, therefore, Joan, not J, Joan. Therefore, it's 1 out of 20. The chances, all right, 1 out of 20. Well, the way we represent chances is in percentage form. So 1 out of 20 means 0.05, and 0.05 means 5% chance. So if we were to select a certain combination with Ben, Danny, and Joan in it, the probability or the chance of picking that combination is just 5%. All right, it's because there's 1 out of 20. It occurs only once in the entire combination of 20 samples. All right, so that's how you answer this question. Now, question number 9 is on the different data types that we learned about. So the qualitative data, quantitative data, and quantitative data can be further divided into discrete quantitative. So let me just draw a picture here. Right, we said data is of 2 types. One is qualitative, and the other is quantitative, right? So qualitative data is data that comes to us in the form of names, categories, and so on. And quantitative data, as the name suggests, is numerical data, right? Numbers. We get the data in the form of numbers, and quantitative data can be further divided into 2. One is discrete data, which is also countable data. Anything that you can count is discrete quantitative data. Anything that you measure is called continuous. That means it'll come in the form of decimals, all right? Continuous, it's measurable data. All right, so based on that, let's look at this question and they're asking us basically to identify what each kind of data is in this table. So the following table gives the top 5 movies at the box office this week. And the first column is ranked, and the next one is what the rank was last week. Then we have the movie title, then we have the studio, or the name of the producing studio, and then box office sales dollars in millions of dollars. All right, it's not $35.2, it's $35.2 million, right? Now, what kind of data is provided by the information in each of the columns? If quantitative, specify discrete or continuous. So column 1 is rank. We see rank is always integer values, countable, right? So it's discrete, quantitative. It's numerical data, but it is discrete. Last week's is also discrete, quantitative. It's not decimal, it's not measurable, it's countable. Then the third column is movie title. It comes to us in the form of names. Movie title is a name, it's not a numerical value, so it's qualitative. Correct? It's qualitative. Make sure you get the spelling right. Qualitative. Then now column 4 is studio, which is also qualitative data. Qualitative. And then column 5 is box office sales, millions of dollars. Now this is a little bit tricky, although we see decimals here. Just try to think a little bit. What do we do with money? Do we count money or do we measure money? We count money, right? Money is not a continuous quantitative value. It's a discrete quantitative value. So we have to say discrete quantitative. So it's a little bit tricky because you see a decimal in the like 35.2, 19.5 and so on. However, money is countable. It's not continuous. All right. So just be careful about that. Just because you see a decimal point in the data doesn't mean it's going to be continuous. All right. Just stop and think a little bit before you, write your final answer. All right. And then now we have the last question here. This last question is on the different types of sampling that we learned, right? Now it says here, a study is done to determine the average tuition that undergraduate students pay per semester at a college. Each student in the following samples is asked how much tuition he or she paid for the fall semester. What is the type of sampling in each case? So let's go one by one. It's not like a multiple choice. We have to go through all these A, B, C, D, E types given to us, and we have to identify which one is what kind of sampling technique. Now, A says a sample of 100 undergraduate students at the college is taken by classification: freshman, sophomore, junior, senior, and then randomly selecting 25 from each. So they have classified 100 undergraduate students at a college by their years, by their, by whether they are freshman or sophomore or junior or senior, by their class year. And then from each of those categories, from each of those classifications, they have selected 25 from each. So 25 freshmen, 25 sophomore, 25 junior, 25 senior. This type of sampling is called the stratified sampling. All right. Now, I will go later on. I will go ahead and I will explain the difference between stratified and cluster, which we will come across a few sentences down here. But for now, in stratified sampling, you categorize your population or into 4 groups, and then you represent each of those categories by a certain number. So you draw a certain percentage of students or candidates or items from each of the strata that you divided your population into. It's called stratified. Now, let's look at B. It says a random number generator is used to select a student from the alphabetical listing of all undergraduate students in the fall semester. Starting with that student, every 50th student is chosen until 75 students are included in the sample. This is the systematic sampling method. All right, systematic. You start with at a particular position, and then you pick every nth item or every nth student or every nth person, whatever it may be you're working with. All right, so it's systematic. All right, systematic means you are moving through the rows. All right, in a systematic manner. Every 50th student in this case, right? They are going and picking every 50th. There's a system, a certain pattern you're following. That makes it systematic. Now, number C says a completely random method is used to select 75 students. Each undergraduate student in the fall semester has the same probability of being chosen at any stage of the sampling process. So this kind of sampling, as you can tell, is SRS or simple random sampling. So there's no system as such, right? It's not systematic. It's not stratified because we are not dividing the population into, different parts, into groups or categories. It's plain and simple random sampling. All right, so that's C. And then number D says the freshman, sophomore, junior and senior years are numbered 1, 2, 3 and 4 respectively. A random generator is used to pick 2 of these years. All students in those 2 years are in the sample. This is a situation where we use the cluster sampling. All right, cluster sampling. So we have grouped our population into 4, freshman, sophomore, junior and senior year, and then we randomly pick 2 groups. All right, only 2 group clusters, so to speak. All right, a random generator is used to pick 2 of these years, 2 clusters only. All students in those 2 years are in the sample. That's the property of cluster sampling. All right, the difference, stratified sampling is similar. The difference is in stratified sampling, every year was represented. They drew 25 from each and every year. In cluster sampling, only 2 years are picked. Pick 2 of these years and then select every student in those 2 years. That's cluster sampling. And then finally we have E, which is an administrative assistant is asked to stand in front of the library once Wednesday and to ask the first 100 undergraduate students he encounters what they paid for tuition the fall semester. This is what we call convenience sampling. This is not really a good scientific way of performing sampling, conducting a sampling technique. It's convenient sampling. It's not randomly selected. All right. So this completes the questions on worksheet, the first worksheet on chapters 1 and 2. Make sure you are able to work on them. You understand why we came up with these answers, because you're going to get similar questions in the test as well. All right.